In this video, I've put some practice questions on electronics information for you to prepare for the ASVAB test. A fuse rated at 0.8 amperes blows when the switch is closed. If an 80-volt supply is supplying power to the circuit, what would be the maximum possible value of the resistance for which the current flows through the circuit? So it's given here that the fuse is rated at 0.8 ampere, which means that the current will continue flowing through the circuit when the current is limited to 0.8 ampere. So according to Ohm's law, current is just equal to the voltage divided by the resistance in ohms. Now take note that the circuit, the current is limited to 0.8 ampere only. So let's take a look at the choices here. The first option will give us voltage, which is 80 volts, divided by 100 ohms. This will give us 0.8 ampere, which is just equal to the rated voltage, and the current will flow through the circuit. This is just exactly equal to this. How about the second one? So 80 volts divided by 90 ohms, and this would give us 0.89 ampere. The next one is 80 volts divided by 80 ohms, and this would give us 1 ampere. And then the last option is 70 ohms, so that would be 80 volts divided by 70 ohms, which is just equal to 1.14 amperes. So among the choices here, only the resistance that is equal to 100 ohms, that would give us 0.8 ampere. The rest are greater than the rated current. So the answer here is 100 ohms. That is the maximum possible value of the resistance for which the current flows through the circuit. What is the total amount of energy if a 12-coulomb charge produces 3 volts? Voltage is defined as 1 joule per coulomb. So that is voltage equals joule per coulomb. That we're given here the charge, which is 12 coulombs, and voltage. So we now solve for the amount of energy in joules. So that will be joules equals voltage times the charge. So that is 3 volts times 12 coulombs. This would give us 36 joules. So the answer is this one. Which of the following statements are correct regarding a voltmeter? A voltmeter is used to measure current. A voltmeter is used in parallel to a circuit. A voltmeter must have the least resistance, or all of the above. A voltmeter is used to measure the potential difference between 2 points, and it is used in parallel with a circuit when measuring voltage. So ideally, a voltmeter should have high resistance so that no current flows through it while measuring the potential difference between the 2 points. So the answer here is this one. A voltmeter is used in parallel to a circuit. Which of the following statements is correct? Conventional current flows from positive terminal of the source to its negative terminal through the circuit. Electron current flows from positive terminal of the source to its negative terminal through the circuit. Conventional current flows from negative terminal of the source to its positive terminal through the circuit, or both option A and B. So the answer here is this one. Conventional current flows from positive terminal of the source to its negative terminal through the circuit. So electron flow is the flow of electrons which actually occurs in a circuit. The electron current flows out of the negative terminal of the source to the circuit to its negative terminal. And the conventional current was chosen as a convention at the time of discovery of electric currents. It assumes that the flow of current is out of the positive terminal of the source through the circuit to its negative terminal. What does the following image represent? Fixed resistor, rheostat, capacitor, potentiometer. So we're given here this image here. So this figure given represents a rheostat. Rectification is an important application of a diode. Rectification can be defined as the conversion of DC into AC, boosting AC, the conversion of AC to DC, or boosting DC. Rectification is an important application of a diode. So it is the conversion of alternating current which reverses its direction periodically to a direct current which flows in only one direction. So the answer here is the conversion of AC to DC. Which of the following statements is correct regarding inductors? An inductor blocks AC but allows DC to pass. An inductor blocks DC but allows AC to pass. An inductor blocks both AC and DC. Or an inductor allows both AC and DC to pass. The answer here is this one. An inductor blocks AC but allows DC to pass. An inductor resists the change in current, that is why it blocks AC. The equation of an inductor is di per dt equals V over L, where di over dt here is the instantaneous rate of current change in amperes per second, ampere per second, while V is the instantaneous voltage across the inductor and L is the inductance in henries. So if you apply direct current across an inductor, it will stabilize to some current flow based on the maximum current available from the current or voltage source. So in this mode, the inductor presents very low resistance, so it can be said that it allows DC to pass. What is the unit of measurement for resistance? The answer here is ohms. In a transformer, the primary coil is the one that is connected to the source. The secondary coil is the one in which an electric current is induced. A larger number of secondary coils means a larger voltage, or all of the above. The answer here is all of the above. So a transformer uses the properties of an inductor to transform the level of voltage in a circuit. AC flowing in wires wrapped around an iron core magnetizes the core and in turn produces a changing magnetic field on the core. So this changing magnetic field generates a voltage in a neighboring coil of wire depending on the number of turns on the wire in the primary versus the secondary coil, and a smaller or larger voltage can be induced in the secondary coil. Which of the following is true regarding an AC signal? The greater the time period, the greater the frequency. The smaller the time period, the greater the frequency. The time period of an AC signal is directly proportional to the square of the frequency. Or there is no relation between the frequency and time period of an AC signal. So the answer here is the smaller the time period, the greater the frequency. So frequency is the number of occurrences of an event per unit time. And the relationship between the frequency and time period of an AC signal is F equals 1 over T, such that frequency is inversely proportional to the time period of an AC signal. So the smaller the time period, the greater the frequency of the signal. 4 bulbs are connected in a series parallel circuit as shown in the given figure here. Each bulb is exhibiting a resistance of 4 ohms. If one of two bulbs in parallel connection blows up, then what will the effect on the total effective resistance offered by all the bulbs? The total effective resistance will decrease, the total effective resistance will increase, the total effective resistance will remain the same, or the circuit will be open. The answer here is the total effective resistance will increase. So the resistances are added in series. It says here series parallel circuit. So the equivalent resistance offered by two bulbs in parallel connection would be we have 1 over 4 plus 1 over 4. 1 over 1 over 4. Raised to the negative 1 equals 2. So this would become 1 over 2 over 4, which is equal to 2. And it would become 1/2 equals 4. No, we flip this, be 4 over 2 over. So the effective resistance offered by all the 4 bulbs in this case would be 4 plus 2 plus 4, which is just equal to 10 ohms. So if one of the bulbs in parallel connected blows up, then the effective resistance offered by all 4 bulbs would be 4 plus 4 plus 4, which is equivalent to 12 ohms. Therefore, the effective resistance will increase. Which of the following is a unit of power? Joule per second, watts, voltage, ampere, all of the above. The answer here is all of the above. So power is the rate of doing work. That is, power equals work over time, which is just joule per second. And electric power is described as power equals voltage times current. And the unit of power is watt, or W. And power is also the product of current and voltage. So it can also be written as voltage times ampere, where V here represents the voltage and A is the unit for current, which is ampere. The generated force on a current carrying wire can be increased by increasing the amount of current flowing, decreasing the length of wire, decreasing the strength of the magnetic field, or all of the above. So the generated force on a current carrying wire is directly proportional to the amount of current flowing, the length of the wire, and the strength of the magnetic field. So increasing any of these will increase the force on the wire and the capacity to do work. Therefore, the answer is increasing the amount of current flowing. A microwave is consuming 800 watt power using a standard North American 120 volts power supply. What is the approximate amount of current flowing? So the formula of finding electric power is power equals voltage times current, or P equals V times I. So if we're going to derive or rearrange, we have current equals power divided by voltage, because we're given here the power and the voltage. So we just plug in all the values. 800 watts divided by 120 volts to get the current in amperes. So 800 divided by 120 is 6.67 amperes, which we don't have here in our choices, so we can just round this off to 7 amperes. The answer is 7 amperes. This one.